In today's lesson, we'll be looking at how to solve quadratic equations. We're first going to define what those are, and then we will learn about several different ways we can attack solving quadratic equations. Recall that a linear equation in one variable is an equation of the form ax to the first, understood here, plus b equals 0. These are first degree equations because the highest exponent on the variable is a 1. Now, for quadratic equations, our highest degree exponent is going to be a 2. Looking in the purple box for the definition of a quadratic equation, it says let a, b, and c represent real numbers where a, the lead coefficient, is not equal to 0. If that a value is equal to 0, then that would reduce this to just a linear equation, and that's not what we have. Okay? So as long as a is not 0, then we have a quadratic equation in the variable x is an equation of this form: ax squared plus bx plus c equals 0. That's called the standard form for a quadratic equation. And the first type of method we're going to use to solve a quadratic equation is by using the zero product property and factoring. So we're going to have to know how to factor very well. If you need to review section R.5, that is where the factoring techniques were reviewed. It says to solve a quadratic equation, we're going to make use of the zero product property, which states that if you have two factors, in this case m and n, being multiplied together to give you 0, then one or both of those factors have to be equal to 0. So in words, what we're going to do is we're going to take our quadratic equation and we're going to write that as a factor times a factor equals 0. Then, by the zero product property, we can say that the first factor equals 0 and then the second factor equals 0, and then we'll solve each of those equations from there. Let's look at a couple of examples. This first example says to solve the equation y squared equals 18 minus 7y. When solving a quadratic equation, our first step is to always get everything on one side equals 0. So to accomplish that, I really want to leave my quadratic term, that's the y squared term, over on the left-hand side because it is a positive 1y squared, and I'd like to leave that alone. So I'm going to add 7y to both sides, as well as subtract 18 from both sides. Now I know we got a lot going on here, but once we get it cleaned up, we will have y squared plus 7y minus 18, and all this stuff on the right-hand side falls out, so equals 0. That's the first place that you start, by moving everything to one side, then equals 0. Next, we're going to factor this left-hand side. This looks to me like one of those quadratic trinomials that we think could possibly unfoil. That's the type of factoring we want to do there. So when we are thinking about unfoiling this quadratic equation, we want to find the two numbers that multiply together to give us the constant term of negative 18, but then combine, or add for short, to give us 7. So what two numbers multiply together to give you a negative 18, but combine together to give you a positive 7? That would have to be the two numbers positive 9 and negative 2. Agreed? So we think how this thing is going to factor is y plus 9 times y minus 2. And if you want to pause and mentally FOIL that out just to check your work, that's a good idea. Now what we're excited about at this point is that we are to the step where we have a factor times a factor equals 0. So we're going to take each of these factors and set them equal to 0. We know we can do that because of our zero product property. Some texts call this the zero factor theorem. Either way, you're now going to split this apart into the two equations and solve from there. So to solve this first equation for y, I will subtract 9 from both sides, and I will have my first solution of negative 9. Over here on this other equation, I can solve for y by adding 2 to both sides. So my next solution is y is equal to positive 2. Now, you should be able to go back up into your original equation and check both of these. We do have two answers, therefore our solution set looks like negative 9 and 2. Or, the order on that of course doesn't matter, but it is a positive 2 and a negative 9. Either one of those two solution sets will work. Now what I was meaning by the checking, okay, and of course I want to check the positive because that would just be easier, but if I want to show you how to check a 2, go back in your original equation, and it said y squared equals 18 minus 7y. That was the original equation. Now if I'm checking 2, 2 squared should be equal to 18 minus 7 times 2. Over here on the left-hand side, 2 squared is 4. 18 minus 14 also gives us 4, so that checks. We could also check a negative 9. Positive 9 won't check, but negative 9 should. And that would look like negative 9 squared should be equal to 18 minus 7 times a negative 2. I don't know where I got a negative 2. I'm not checking negative 2, I'm checking negative 9. That was crazy. So negative 9 squared is a positive 81. Here I have 18, and negative 7 times negative 9 is positive 63. And 18 plus 63 does give me 81, so the solution of negative 9 checks as well. We know we have the correct solution set down here. Now, on these quadratic equations, our solutions are going to get pretty ugly pretty quick. These are beautiful, nice little integer solutions, but a lot of times we're going to get rational solutions and irrational solutions, and we can even get complex conjugate solutions. We'll see all of those examples coming up in this section. Let's do number 12 on example 1 in the next video.